Compare and contrast polar and non-polar molecules and use the concept of like dissolves like. What are most substances in rivers that are found in rivers? What are they like? Are they ionic? Or is it a bunch of metals? No, those are really strange things. Those are contaminations. Most substances found in rivers are molecules. Molecules. So non-metals form molecules instead of ionic compounds. What is the difference between them? Molecules share electrons. Ionic compounds, well, the metal will give its electron to the non-metal. The metal will give its electron to the non-metal. So in a molecule you have non-metal, non-metal. In an ionic compound you have metal, non-metal. Metal, non-metal. Non-metal, non-metal, think of them as pretty girls that want to share the guy. Ben would rather be shared by pretty girls. But if Ben is given the choice between an ugly girl, a metal, and a very pretty girl, a non-metal, he will transfer over to the pretty girl. Right? So what is the difference between polar and non-polar? We got to get back to Ben. Okay? If Ben's choices are two extremely, Haley and her twin sister Staley, Haley and Staley, what will he want to do? He'll want to be shared by Haley and Staley because they're equally beautiful. Equally beautiful. And what we find is that he is just as likely to be on one side as he is to be on the Staley side. Okay? So we can't really pinpoint Ben as being on one side of the molecule or the other. It's symmetrical. It's equal. Equal sharing. So that results in a non-polar bond. But what if it's Haley and let's say a girl who's not nearly as pretty but still fairly pretty, like Pam. Don't know who Pam is, but there she is. She is not as pretty as Haley, but still she's pretty. So Ben, being a red-blooded American male, he will try to date them both, hopefully without either one of them knowing that either one exists. Right, Ben?
Yep.
Exactly. Okay? And like most red-blooded American men, he will fail and he'll eventually lose both of them. Because they'll eventually find out. But the way Ben thinks, it was worth it because for a time, he had two girlfriends, right? All right. So what happens is this. Ben is more attracted to Haley than he is to Pam, so Ben is more likely to spend time with Haley than Pam. So there's an unequal sharing. Haley has more control of Ben than Pam does. So the side that Ben spends more time in, that's the negative side. And the side that Ben doesn't spend as much time, Pam's side, that's positive. So here's Pam, here's Haley. Ben is more attracted to Haley. He's more likely to be near Haley, but he doesn't want to get rid of Pam, so it's not an ionic bond. So we say that the side that Ben is more likely to be closer to is negative. And the side that Pam, where Ben is less likely to be to, that's the positive side. Do you understand the difference between polar and non-polar? Yes? Good. So how does this affect a substance's ability to dissolve another substance? Well, quite simply, polar is going to be attracted to other polar molecules. Non-polar will not necessarily be attracted, but will not be unattracted. Polar molecules will not like non-polar molecules, will not be attracted to them at all. So polar molecules will not be able to dissolve non-polar. But non-polar and non-polar can disperse in each other. In other words, like dissolves like. Like dissolves like. Like dissolves like. Here's a perfect example. This is a permanent marker, correct? This is a board that's designed for dry erase marker. What happens if I use a permanent marker? Now, that sucker won't come off. Okay? I'll get my eraser. Still won't come off. How can I get it off? You see, permanent marker is a non-polar substance. It does not have any poles. Okay, so it sticks to itself. What I need to do is I need to be able to dissolve it in something that is also non-polar. These pens, these dry erase markers, are also non-polar. So all I have to do is mark over it. The permanent marker will dissolve in the non-permanent dry erase, and they both are taken out by, it's called like dissolves like. Girls are far more familiar with this than guys are. Well, I shouldn't say that. Some guys like to paint their nails, and therefore they're going to be familiar with this. Girls, what kind of substance do you use to paint your nails? Do you use polar or non-polar? Okay, maybe you don't know. Ask yourself the question. What happens when I wash my hands to the nail polish? Hold on, hold on. Consider that water will dissolve anything that's polar. Anything that is polar will be dissolved by water. So, what happens when I wash my hands? It stays. What does that tell you about nail polish?
Non-polar.
Non-polar. So what kind of substance would you use in order to get rid of the non-polar? Another non-polar, which is nail polish remover. If you were to pour nail polish remover and water together, guess what it would form?
Foam. I don't know. Foam.
It would form two different layers. Why? Because water, being polar, can't interact with nail polish, which is non-polar. Water would rather stick to itself, so it leaves the nail polish alone. Polar dissolves polar, non-polar dissolves non-polar. So these kinds of questions are fairly easy. All you need to do is ask yourself, can water dissolve it? If water can dissolve it, then it is polar. If water cannot dissolve it, then it is non-polar. All right, nail polish.
Non.
House paint. Okay, think.
I don't know. Wait, that is
Let's think. When it rains water. When the water hits your house paint, does the paint begin to streak away?
Yeah.
slowly after time.
Not necessarily.
I don't know what kind of house paint you guys use.
If it's still
My
wet.
house paint is still on there.
What if it's like wet?
Okay? So, what does that tell you? House paint is?
Non-polar.
Polar.
That's really fun to say.
Okay, so watercolors comes in this little powder. Would you use water or a non-polar solvent in order to dissolve it?
Water.
Okay, so this is polar. What about vegetable oil?
Wouldn't that be non-polar because it like
Polar.
goes two different things?
Okay, can water dissolve vegetable oil?
I don't know.
But
When
would
the
it-
when
would
the
it-
vegetable oil gets in the pan, how effective is water at cleaning the pan?
If you poured it on a wall and you poured water on it, it would streak.
No, it,
Yeah, it might. Water may physically
it will run.
push it,
Yeah.
but water can't dissolve it,
So
can't
polar,
disperse
right?
it.
Why you use soap.
It's non-polar.
Oh, wow.
That's why you would need to use soap. Speaking of soap, how does soap work?
I don't know.
Okay,
I don't know. This is crazy.
It just makes me quaint.
let's see. Somebody with a good sense of humor. You've got a good sense of humor.
No, I
She
Yes.
really don't.
You don't?
Wow. No, I don't. Why?
All right, it's intervention time.
Oh no.
All right? It's intervention. Because we love you, we need to
All my
talk.
dirty is over.
Okay? The people around you have been asking me to talk to you about this because you smell bad. You smell bad. I mean, you've got BO, Emily. All right? So, why? I've called your mom, and your mom says, I don't understand why she smells so bad. She takes a shower every morning, and you do, but I think your mom and I have traced the problem. Remember when you were a little kid, you got soap in your eyes? Okay, that hurt, didn't it? That made you soap phobic. You're afraid of soap. My dear, you've not been using soap. Now we know, folks. See, soap is this funny looking guy here. Soap has an end that is polar. So that ball-like end, that's polar. And then it has a tail that is non-polar. So is soap polar? Yes. Is soap non-polar? Yes. It is both. All right. Here is Emily's hand.
I have 4 fingers. Oh, it's 5 fingers.
Okay? Her skin is constantly making little globules of oil.
Ugh.
No, that's natural. That keeps your skin moist and supple and makes it semi-permeable to water. That's good. You need your oil.
Okay.
You need, unfortunately for you, if that oil spends too much time on your skin, bacteria falls on your skin and starts consuming the oil and producing bacteria poo. Some of the bacteria poo is a gas that emanates off of your skin, and we can smell. So when you're smelling BO, what you're smelling is bacteria poo.
That is so gross.
All right? It is disgusting. So she doesn't like that. So she decides to wash her body with water. Now, oil is polar or non-polar? Non-polar. So when the water molecules hit the non-polar oil drops, it just slides right off and goes down the drain. Okay, it may succeed, if she has a tough enough shower head, it may succeed in brushing some of the oil down, but it doesn't dissolve it. Can't dissolve it. There's nothing about oil that water's attracted to. Oil does not have any poles. Water has poles. Okay? So, my dear Emily, we're all glad you're taking daily showers, but that water alone is not doing anything to get the oil off. So that oil stays there, bacteria consumes it, yucky, we smell the bacteria poo, smelly, smelly, smelly. Isaac's eyes, he leaves, his eyes are watering just from spending. You should have seen the smile on his face the other day when you were absent. It's like, I can breathe today. He was so happy. Okay, it's intervention time. You need to use soap. I know that it's scary. I know that it hurts you when you were a little kid. What's going to happen is this. The non-polar side will orient itself toward the oil droplet and actually lift it up out of your skin, completely surrounding it like this. Now, what's on the surface? The polar end. So what happens? Okay, so she lathers up. When she lathers up, she picks up that oil with the soap. And when she rinses, the water is going to drag this whole thing down the drain. Well, maybe you shouldn't have your nose down in the drain. That is how soap works. And that is what hopefully will get us just smelling a little bit better tomorrow. All right? Here is the explanation using words. Soap has a polar side and a non-polar side. The non-polar side will surround the oil on your skin with the polar or water-loving side sticking up. When the water washes then the water washes all the whole mess away. Why is water known as the universal solvent? No, soap is both polar and non-polar. Water is superpolar. It is the superhero of polar. It is so powerful that it will dissolve anything polar and anything ionic, because ionic is made up of positive and negative things as well.